Okay, we're continuing with section 4.6, and this one is number 7. So number 7, the problem is we're going to be multiplying 1 plus x by 1 plus z. Now the values they give us for x is negative 1 over 5, and the value for z is 7 over 12. Make that correct. Now, if I plug these values in, you can see that we are going to be multiplying by a whole number in each situation. So what I'm going to do is, let me first plug this in and I'll tell you the thought process. So if we had 1 plus, and this one is a negative 1 over 5, and we're going to multiply that by 1 plus, and the other value is 7 over 12. Now, we would prefer to add up, and of course we always solve inside the parentheses first before we multiply. This is based on order of operations. And we would prefer to add up like fractions. So how can I get a like fraction out of each one? Well, if we go over here to look at our values, remember 1 can be expressed any way as long as as a fraction, as long as the numerator and the denominator is the same, meaning 100 over 100, or it could be 5 over 5, or 12 over 12. And the reason why I used 5 and 12 is because I'm going to go look at these. And I'm going to look at the denominator. So I'm like, So when I rewrite this, how about if I rewrite this one as 5 over 5, because that's the same exact thing as the whole number 1, and I'm going to add it to the negative 1/5. So we're creating like fractions. And the same with over here, 12 over 12 plus 7 over 12. So that way we have like fractions. Now when I handle the operation of the first one, it's 5 plus a negative 1, which we subtract, take the sign of the larger number. So that would leave us with 4 over 5. And then the next fraction is 12 plus 7, which would give us 19 over, oops, I didn't write that correctly. So that would be 19 over 12. Now we have two fractions that we're going to multiply. So I'm going to rewrite that as 4 times 19 all over 5 times 12. Now I can see already on the bottom, I can get a 4 out of that 12 because that's 3 times 4. So let's rewrite that one. So if we have 4 times 19 over top of 5 times 3 times 4. Now we can see that the 4's divide out to 1s. And on the bottom, you're not going to get a 19, and 5 times 3 is 15. So we're just going to write that out as 19 over 15. And this is the final answer. So the goal was to see, or to recall, order of operations, meaning you're going to take care of what's inside those parentheses, and also how to get a fraction out of the whole number 1. So on this one, we end up deciding 1 would be 5 over 5, so we could have a like fraction, and this one would be 12 over 12. Okay, so now let's move on to number 8. Number 8, we have, make sure I write this, number 8. Now, number 8 is 1 minus 1/6 squared. Okay, so we know that just means that we're going to have to multiply this twice. So we have this times this, okay? So the same concept applies as the previous problem. If we want to make sure that we take care of what's inside the parentheses first before we multiply, let's make sure we get like fractions. And as you can see, the denominator is 6, so for those 1s, put that. So for the 1s, I'm going to create the fraction 6 over 6. Same value, different appearance. So if I rewrite this as 6 over 6 minus 1 over 6 times 6 over 6 minus 1 over 6, we know we get the value of 6 minus 1 would give us 5/6, and we're going to multiply that out twice. Okay, and then when we rewrite it, it just becomes 5 times 5 over time a 6 times 6. And you can immediately also see, if you're looking at it visually, you would see that it's 5 squared over 6 squared. Same exact thing. So our answer, our final answer, because we can't reduce any of those numbers down, would be 25 over 36. And that's our final answer. And that was for this problem here. All right, now let's move on to the last problem, which is number 9 for this section. So number 9. All right, number 9, now we have negative, oops, that's a little bit big. So now we have negative 7 over 9. And we're going to subtract that by 2 over 9 to the 4th power. Okay, so again, you want to start trying to reduce down as much as you can inside the parentheses, because that's order of operations. You take care of what's side in the parentheses before you take care of this exponent. So off to the side, I'm just going to rewrite this as negative 7 minus 2 all over 9. Oops, let me rewrite that. I'm sorry. So we have negative 7 minus 2 all over 9. And we're still going to solve inside the parentheses before we take it to the 4th power. Now remember, the rule states we're going to change this to a plus sign, make that a minus. So now we know we end up with 9 over 9. So you might start seeing what's happening here. So we have negative 9 over 9 to the 4th power. Now remember, anytime the numerator and the denominator is the same, it's equivalent to 1. If you add a negative to any of those numbers, you're going to end up with a negative answer. So that's why to the 4th power, this one's pretty easy, because we have negative 1 to the 4th power. Now, no matter how many times you multiply 1, the answer is still 1. The question is, you're going to ask yourself, is it going to be a negative or a positive? And whenever you have a odd exponent, you're going to end up with a negative answer. If you have an even, you're going to end up with a positive answer. So let me just show you how it looks. So if you have negative 1 times negative 1, that would give you a positive 1. And then we multiply it a 3rd time, this gives us a negative 1. And if we multiply it by a 4th time, oops, negative 1, then you can see how we end up with a positive answer. So we did it 1, 2, 3, 4. These were just the answers when we were multiplying it out. And that's why we end up with a positive as the final answer. So now we're going to move on to the next video, which is section 4.7.